That's right. So once again, we started on Monday with the mean, median, and mode, and we also computed the range. I give you guys steps for that, and we've been practicing that. So for today, we're going to be looking at standard deviation, but we're also going to start representing data on dot plots. So can you read us the objective, please? Nate.
I can represent data on dot plots using standard deviation.
On 3, 1, 2, 3.
I can represent data on dot plots and compute standard deviation.
So standard deviation, we already introduced it yesterday, left it for home play, and you did plenty of practice, yes? Okay. And so for today, we're going to look at dot plots. What are dot plots? Oh, let me go back to the objective so you can write it down. I'll leave it up there on the screen. Dot plots, what are they? Dot plots is a data representation that uses number line, X's, dots, and other symbols to show frequency. Dot plots is a data representation that uses what? Number line, X's, dots, or other symbols to show frequency. So let me show you an example of what a dot plot looks like. Look at it. Does it have a number line? Yes. Are they using X's, dots, or other symbols? Yes. And does it show frequency? Yes. And we'll read it in a little bit. Just copy that for right now. I'll give you some time. Ready, go. So look at that dot plot. It has a number line. It's titled Salary in Thousands of Dollars. Okay? So look at it, and I want you to answer this question. Which salary has the most frequency? And how many are there in the most? Talk it over with your neighbor, and then I'll call on someone. All right, let's see what you get for this. Jerry. Hands if you agree with 35 and 40. That is incorrect. Who said 35,000 and 40,000? What? Yeah. Even though the chart says 20, 30, 40, 50, but what does it say in the instructions? In thousands of dollars. That's why I was asking the question, which salary has the most frequency? And yes, it's 35,000 and 40,000. Tell your neighbor which one has the least frequency. The least frequency, not the least amount. All right, so you agree that the least frequency is 25,000, 30,000, 50,000, and 60,000. Is that correct? And yes, that's how we read dot plots. So now let me show you what is not a dot plot. Look at it. Copy that. It says number of A's and grade period. As you're copying that, start thinking this is not a dot plot because blah, blah, blah. So copy that. I'll give you some time. Go. All right. So you're looking at the non-example, and you're looking at the examples. Talk it over with your neighbor. Tell them why the example is a dot plot and the other one is not a dot plot. All right. Let's see who can elaborate. Let's see. Jerry, pass to someone. Leslie R. Why is one a dot plot and the other not? because it doesn't have just a number line. This one has a quadrant. Do you guys have notice that it has an X and a Y? Yes, and the other one only has a one number line. So that's pretty much the obvious thing. But do they both use show frequency? Yes. This one says how many A's, number of A's? 5 in the first grading period, 6 in the second, and so on and so forth. It shows some sort of frequency. So let's hashtag this. What makes this a specific dot plot? We can get it started. Go ahead, Mia. Hashtag number line. Maria. Hashtag X, X's, and dots. How about we change X's and dots to X's and O's? Get it? No? Never mind. Let's see. Nate, go. Plots. Kelsey. Show frequency. And that's pretty good, right? Okay, write that down. So now that we know what dot plots are, and I also gave you steps, notice that we already have been doing step 1, which is mean, median, mode, and range. Is that correct? We already introduced standard deviation, but I just want us to do one together to make sure everybody finalizes that to make sure we can move on. But today we're going to be graphing on dot plots and summarizing our data with a statement. So with that said, underneath your steps, copy this data and table. Copy the data and table. And for this one, we're not going to find mean, median, mode, and range since we already know how to do that. What I want us to get to first is do standard deviation. So that's why I asked you to copy the data and the table, and then we'll get started. I'll give you about a minute so you can copy that. Go. All right. Now that we copied it, let's go through the process together to make sure we can move on to dot plots. To find standard deviation, what is the first step that we do once we are given data? Paulina. Least to greatest. So we start with 1, 2, 2, 3, 4, 5, 6. Always arrange data from least to greatest. So like that, you can get started doing whatever they're asking you to do, whether it's finding the mode, the median, the range, chi, or whatever the case. Now that we have it in order, what do we do from there? Brian. What do you mean? Have to find the mean. How do we find the mean, or chi? Okay, so how much do you have if you add them up? 23, Michael Jordan. And how many items do we have? 7. So we divide by 7. That's going to give us our chi. Round to the nearest hundredth. Okay, who's got chi already? Chris, what'd you get? I have -3.29. Oh, 3 point what? 29. Hands, if you got that? Only one. Let's see. 7 times 3, that's 21. Subtract, that's 2. Add a decimal and a 0. Fits in there 2 times, that's 14. Subtract that 6, add a 0. That becomes 8. 8 times 7, 56. Subtract, that's 4. Add a 0. Fits in there 5 times, that's 35. And it starts with 5, so this one becomes a 9. That is correct, 3.29. So for the next column, they're asking us to get the number and subtract chi. So we have 1 minus chi, which is 3.29. 2 minus 3.29. 2 minus 3.29. 3 minus 3.29. 4 minus 3.29. 5 minus 3.29. And 6 minus 3.29. So on the next column, in parentheses, squared, we're going to write the difference of each one of each of those numbers and square it. And for this column, you're going to need your calculator, so get a tab open on your iPad. There should be a calculator there already on the iPad. So let's see, 1 minus 3.29, that's negative 2.29. Yes? Yes, Mr. Q. 2 minus 3.29 is negative 1.29. It's the same one, negative 1.29. 3 minus negative 3.29, that's negative 0.29. 4 minus 3.29, that's 0.71. And this is 1.71 and 2.71. So get your calculator, square those so I can start calling people to give me the squared value first. I'll give you some time to fill that in. Copy that in, go. Okay, let's see. What is negative 2.29 squared, Maria? Oh, okay. Error calculator and 2.29 squared. .24. Hands if you got that. That is correct. What is negative 1.29 squared? Roman, Carlos. $1.14. Hands if you got that. Okay. 1.14. Okay. Yes? Okay, who got something different for 1.29 squared? Jerry. 1.6 what? That sounds more like it. So it's 1.66. Hands if you got that. That is correct. Write that twice. 1.66, 1.66. What is 0.29 squared or negative 0.29 squared? Jaden, what'd you get? 0.08. Hands if you got that. That is correct. How about 0.71 squared? Jaylene. 0.50. Hands if you got that. Okay, so far so good. 1.71 squared. Roman, Aguirre. 2.89. Hands if you got that. We got something different? Kelsey? 2.92. Hands if you got 2.92. I think that sounds a little bit more like it. 2.92. And the last one, 2.71 squared. Danny, what'd you get? $7.34. Hands if you got that. That sounds about right. All right. Now check this out. Here, oh, sorry. Here it says squared deviation. What does that mean? That we need to find the deviation squared. What does that mean? That we need to find the mean again of this, chi. So what do, everyone? Add them up and then divide by whatever. First, give me the sum. Add these up really quick. I'll give you 30 seconds. Add them up. Got the sum already? Someone's got the sum? Jaylene? 19.4. And then we're going to divide by what, everyone? 7? Okay. Divide by 7. All right. Who's got standard deviation squared? Leslie. C. 2.77. So far, so good. Are we there so far? But are we done? No, they're asking for the standard deviation, so we need to cancel this squared. How do we do that? Square root, square root. Therefore, who can give me the standard deviation of that data? Roman. Plus, minus, approximately 1.66. Hands if you got that. That seems about right. So let's go through the process to make sure we got it. First, we are given data. We arrange it from least to greatest. Are we there? We find chi by finding the sum and dividing by the number of numbers. There it is. Get all the numbers, subtract them by chi, get the difference and square each one. Find chi again for the squared deviation, and then at the end take the square root for the standard deviation. Are we there? Fairly simple? Yes, Mr. Q, we love these. All right, good. Therefore, from 1 to 5, how do you feel with standard deviation up to right now? So let's move on to dot plots. So write your utensils down, look up to the screen. This is very simple. Pretty much they give you a table, and all you have to do is translate that into a dot plot to see the frequency. And then from there make decisions as to what the data is about. So look at the example 2. An ice cream truck offers items at 5 different prices. Mr. Q counted how many items were offered at each price one day. Make a dot plot of each data. By the way, this is true. Like sometimes I'm doing my yard work and then I go and I'm waiting for everybody like to buy their stuff that are in front of me, but I can't stop thinking about patterns. I don't know what it is. So I look at all the prices and I saw the pattern and I saw, okay, I see this price, and I'm thinking like, how come they only have those prices? That's a good question, right? Somewhere you're like, I would just buy my churritos or whatever. Anyways, so to make a dot plot, here goes the process. You are given a table, there it is. You make a number line, like I have there, and then all I have to do is translate the information onto the dot plot. However, I need to scale this according to my x. This is my x. Let's see. The prices are 1, 150, 2, 250, and 3. By how much increments am I going to use each tally? Oh, I'm sorry. How about yours? Okay. So by how much am I going to label each tally for increments? $1, $2, $3? That much? So go by how much? Okay, good. I'm going to go by 25 cents. 0.25, 0.50, 0.75. That means this one is what? $1. 0.25, 0.50, 0.75. That means this one is what? $2. 0.25, 0.50, 0.75. That means this is $3. So I'm going to stop right there. So this is how you plot your dot plots. For the $1 price, how many? The frequency is 1, 2, 3, 4, 5. For 150, 150 is right here, so it's 3, so it's 1, 2, 3. $2 at 6, 1, 2, 3, 4, 5, 6. 250, which is here, it's 4, 1, 2, 3, 4. For $3, it's 2, 1, 2. Look at this plot. Tell your neighbor, what can you conclude from the data display according to that problem? Tell your neighbor what you can conclude. All right, let's see. Summary, go ahead, Melanie. Most kids buy $2 items. Is that correct? Yeah, if you're someone that has a business and you look at that, the majority like the $2 items, well, guess what kind are you going to have on that truck? $2 items. All right. Copy this next one, please. Copy the table. Make a dot plot and answer the question. And there's the problem at hand. It says, the cafeteria offers items at 7 different prices. Mr. Lopez counted how many items were offered at each price one day. Make a dot plot of the data, and I want you to answer the question. What can you conclude from the data display? I'll give you some time. Copy that and go. You got 1 minute. So for tonight, home play for tonight, you have a play sheet. Home play is the play sheet. It's on top of the cart. If you didn't get one, make sure you get one before you leave. There is tutoring. Vamos, see you guys tomorrow. Bye.